Welcome to the third lecture in CIT 230, Advanced Java Programming. We're going to start today by talking a little bit about polymorphism. If you remember from the last two lectures, we've talked about the three pillars of object-oriented programming languages. We started by discussing encapsulation, which is used to hide the implementation of our code from the consumption or use of that code. Then last class, we talked about inheritance, where we built classes that derived methods and properties from other classes. Today we're going to talk briefly about polymorphism, a third concept. We're going to talk more briefly about it because in terms of examples, to do a full class example in polymorphism is a little bit more contrived. So I'm going to talk a little bit about what it means and show some places where it can be seen, and then we'll see examples throughout the rest of the course this semester. So let's start by talking about what polymorphism is. When we talk about polymorphism, what we're really talking about is the fact that any object of a particular class is also an instance or an object of any class that is up the inheritance chain. Or I could also say that any object of a particular class is also an instance or an object of the superclass of the object's class. What I'm saying there is, if we go to what we talked about last week, remember in inheritance, all classes inherit initially or at the top of the inheritance chain from object. The object class is what everything derives from, meaning that due to polymorphism, any object is an instance of the object class. More specifically, if you remember last week when we talked about inheritance, we talked about a vehicle that might have a speed and a direction and methods to change those, and then we got more specific with the motor vehicle and the car. What polymorphism tells us is that every object of type car is also a motor vehicle. Any object of the type motor vehicle is also a vehicle. Any object of the type vehicle is also an object. But it goes all the way up the inheritance chain. So while I said that a motor vehicle is also an object of type vehicle, it is also an object of type object. And a car, while also a motor vehicle, is also a vehicle and an object. Hopefully this is intuitively true. If I say that I am a person, you can intuitively understand that I'm also a mammal or that I'm also an animal. Those are things that follow from each other. Animals include lots of other things, but it does include people or persons. Now, one of the important things about polymorphism is it's a one-way relationship. I like to say that polymorphism is the yang to inheritance's yin. Really, when we're talking about polymorphism, we're talking about the backwards relationship. Every car is an object, but clearly not every object is a car. And that's an important distinction. So why do we talk about polymorphism, and why is it something that is important to our object-oriented languages? The reason it's important is if I'm creating a new method and I'm thinking about what type of object I want to be passed in to that method, what is best for me to do is choose the broadest class type that makes sense. For instance, if I were making a method for some kind of racing game, and I allowed within that racing game for there to be cars and motorcycles, when I made a method for selecting or creating the thing you'd be driving, I could make a method that allowed for doing things with a car, but then I would also have to make a second method that allowed me to do motorcycle, which would be sort of another thing that inherited from motor vehicle. It makes more sense to make the method use motor vehicle, and then I can pass in either a car or a motorcycle object because both are motor vehicles. I don't have to specifically make two different methods, one for cars, one for motorcycles. I can make one for motor vehicles. And then that also allows me to, let's say, if we decided SUV or truck or things like that were also separate motor vehicles that we might want to do, all of those could be passed in, because if they inherited from motor vehicle, every car is a motor vehicle, every truck is a motor vehicle, every motorcycle is a motor vehicle. So let's look at this from a different perspective by looking at the API documentation like we have come accustomed to in the class thus far. If you remember in the last lecture, we talked a little bit deeper, went quote unquote under the hood a little bit on exceptions. So when we went into java.lang, we talked about a couple of different kinds of exceptions, and through that we talked about the concept of checked exceptions versus unchecked exceptions. Checked exceptions, such as illegal action exception, do not have runtime exception in their inheritance chain, whereas unchecked exceptions do have it. One of the things that that polymorphism tells us is that all illegal argument exceptions are runtime exceptions. All illegal argument exceptions are exceptions. All illegal argument exceptions are throwables. All illegal access exceptions are reflective operation exceptions. All illegal access exceptions are exceptions, and so on. What does that mean to us in a practical sense? Let's take a look at a code snippet. If I have a block of code that started something here that had object1 dot method 1 that, took in x and y. And then I had object2 dot method 2 that took in zw. And I had object3 dot method 3 dot mn. And we're just going with very generic pretend objects of unspecified classes with unspecified methods here, because I want to make a point, and I don't want to get caught up in what these things do. But let's just say each of these methods have the possibility of throwing one or more different exceptions, and those exceptions might be of different types. What some programmers I've seen might do is something like this. Catch exception E. And then in here, they just do something, whatever that happens to be. While polymorphism allows us to do this, because if this throws an illegal argument exception, while this throws an array out of bounds exception, while method 3 throws a file not found exception, all of those exceptions, as we've said before, all those specific type of exceptions are also exceptions because every one of them has exception in the inheritance chain. As I click on these, and if you just pay attention to where I'm clicking, you'll see every single one of them has exception. So this will work because of polymorphism. Now this specific thing, again, while there are times to do it, is generally done out of laziness. Frequently, with different kinds of exceptions, we want to do something very different. For example, if the first one threw an illegal argument exception, we may want to let the user know so that they go back and re-enter the data. But perhaps it also makes sense that if they put in something invalid, that we clear out all of the other variables. So it might make more sense to do something like illegal argument exception, IAE, and then do something. And then for our second one, do an array out of bounds exception AOOBE, something like that. And this would be do something else. Because with the array out of bounds, maybe I, instead of telling the user to re-enter some data or something like that, maybe I want to reset the pointer to the beginning of the array and return that item. Something like that. What we have to be careful with, because of polymorphism in this case, is sometimes we may have the array index out of bounds exception. We may have one method that throws an array index out of bounds exception. We may have a different method or a different circumstance that throws an index out of bounds exception. So if I go back to my theoretical example, and I meant for it's array index out of bounds exception. If I here did catch index out of bounds exception IOOBE, and I do another thing, whatever all that is, any of these methods that throw an array index out of bounds exception, this code would never fire because of polymorphism. Since an array index out of bounds exception, and hopefully an array index out of bounds exception is also an index out of bounds exception. When the exception is thrown, the code is interrupted and it starts to go down, and it says, did it throw an illegal argument exception? No. Did it throw an index out of bounds exception? Yes. And by polymorphism, an array index out of bounds exception is an index out of bounds exception. So every one of them, whether it's specifically an index out of bounds exception or an array index out of bounds exception, would fire this code. What we want to do alternatively to prevent that from happening is put the more specific catch statement above the more general catch statement. That way, an array index out of bounds exception will be caught by this code, and an index out of bounds exception is not an array index out of bounds exception, so it will go to the next piece. So it's just sort of a something to keep in the back of your mind. There aren't a lot or a ton of examples of this, but it is something to keep in mind. And one of the things you may want to do as sort of a catch-all is end your set of catch statements with a catch exception E, and here you may want to do something generic that indicates an unexpected exception was thrown. Something that lets the user know, wow, something really weird happened, and maybe we want to provide, as a developer, we want to provide something that they can give the help desk that gives special information for them to help the end user or whatever. If polymorphism seems a little difficult to understand right at this minute, don't worry about that. We will see quite a number of examples as we move through the class, this course. So starting next time when we do start looking at event handling, we'll start there with examples where we can see how polymorphism works. But before we get to that, we want to look at simple graphical interfaces. So one of the things that is good to know or important to understand is in the history of Java, initially graphical interfaces were done with what's called AWT, or the Abstract Windowing Toolkit. This was the initial methodology or the initial platform by which we made graphical interfaces. Unfortunately, that framework has a number of disadvantages to it, primarily due to operating system differences. So if I wrote a graphical interface for Windows, it might not look or feel or perform exactly the same on a Macintosh or a Debian Linux machine, something like that. So quickly, the Java team, the inventors of the language, determined that what was needed was something a little more platform independent, because platform independence is a critical part of the design of Java. So that's when the Swing library or Swing platform was created. And Swing was a very robust, very flexible, very easy to work with platform that was actually built on top of AWT to take care of the inefficiencies that we got from AWT specifically, and Swing lasted for a really long time, really the better part of a decade or more. Swing was the predominant way to create graphical interfaces within Java. But with the rise of variable-sized devices, as we got smartphones, tablets, more portable laptops, and contrasted with workstations with large screens, we needed our interfaces to be a little more adaptive, so that what we saw when we worked on a phone wasn't vastly different than what we saw when we worked on, say, a laptop or a workstation. So what they had to do was create a new library called JavaFX. And this is what is the primary primarily used set of packages or libraries for doing graphical interfaces today. So we're going to do all of our work this semester in JavaFX. Now, it is a complete, from the ground up build of a graphical interface platform, so it doesn't rely on anything from Swing by default, and it doesn't rely on anything from AWT as well. So this is where we're going to start. So I'm going to do a really, really simple, we'll call it a test program for the employee class we built last week. So the first thing is, like all of our Java programming, we're going to start with public class, give it a name. I'm going to call it employee test FX. That just means this is a program that tests our employee class. It's not really meant to be an application used by the general public, but just to make sure that we can create objects out of it and that it all works. And we're going to do that with the with a graphical interface. We're going to inherit from application. This is one of those places where we're really, really going to see the power or the real meat of inheritance. As we're used to seeing from everything we've done thus, using applications, not writing them, but using applications, Graphical interfaces have with them a lot of stuff. You see, it's like a window that I can drag around. It has this title up here. It has the ability to minimize. It has the ability to restore. I can maximize or restore. I could click on this X and close it. I can click in the corner here and custom, make a custom size out of it. These are all things that are somewhat universal within graphical interfaces. So I want those things in all of my programs. And imagine if every time I wanted to make a graphical interface, I had to build all that stuff into it. That would take a lot of time, and it would be incredibly repetitive. Well, a big part of our JavaFX platform is there exists a class called application, and that class takes care of all those pieces I was just talking about for me. So we're really getting a lot out of inheritance here. One of the things that we're going to start seeing because of JavaFX is the number of import statements is going to greatly increase. Now, I'd like to take a quick aside at this point. One of the things that you'll notice about me is one of my styles is sometimes you'll see me specify the class I'm importing, and sometimes you'll see me do the wildcard. When we are working with these packages, and in a few shortly in the class, not today's lecture, but in a lecture coming soon, we will learn how packages work and what they are. But given a particular package, like in this case, java.fx or javafx.scene.control, I'm sorry, javafx.application or javafx.scene.control, you'll notice that any of these have more than one class in them. There's, about 7 or 8 different classes that are part of the application. And under scene control, there's a really large set, several dozen classes that are all really, truthfully, interface elements like buttons and radio buttons and text boxes and labels and drop-down lists and sliders and all that stuff. When we work with those items, we often need more than one. What I like to do is, if I'm using only one class out of a package, I specify. If I'm going to use more than one, I use the asterisk. And in this case, I'm going to use 3 or 4, I think 3 or 4 controls in this interface. Now you might ask, so what's the difference and why would I make decisions like this? So ultimately, importing packages does nothing specifically to my set of code. It doesn't have any performance hits because it is linked. If anyone's ever worked with or looked more carefully at things in, say, Windows programs, you're probably familiar with the concept of a DLL or a dynamically linked library. Java uses the same concept where we're linking out to the JavaFX application package to run things that are part of the of it, like the application class. So by including star or asterisk, I don't get a performance hit, because when I use the button control or the radio button control, it just links out to those. There's no issue. So you might say, well, why don't I just use star every time? One of the things that we have to always think about when we write code is the readability of that code, particularly for debugging. When we start to have 20, 30 import statements for code that goes on for 1,000, 2,000 lines, what can happen is someone's having a problem in a section around line 800 of the code with a particular method call on an object. And it can be somewhat arduous to determine where do I find the API documentation for the class associated with that particular object. When we specify which classes we're using, it's very easy. I know that application is in javafx.application. And so what you'll see a lot of programmers do is they will never use the asterisk. They'll specify every time. That can be very, make it very easy to find what you're looking for, but you have to weed through a lot more import statements. So instead, what I like to do is use asterisk when it's more than once, and then I'll add some kind of comment that says something like, this package contains the label, text field, and radio button classes. Now, what I've got is the best of both worlds. I don't jam-pack too many import statements, but people can find stuff real quick. That's how I do it. Again, your mileage may vary. This is a matter of style or preference, not convention. So do whatever makes you most comfortable, or whatever philosophy makes the most sense to you as an individual. Going back to the specifics of creating this particular application, again, all JavaFX applications are going to extend application, so we get that cool framework, the window, the resizability, the action on the X, the minimize, maximize, all those things we get for free as part of our application. So one of the things that is going to look or feel a little bit different for us right now is instead of public void, public static void main string args, we're going to do public void start stage primary stage. So what does that mean? If you remember from your introductory Java class, whenever you created something that was runnable, that would run, you had to put the main in there. That is because the Java runtime environment, or the virtual machine, is looking for you to tell it, when you tell it to run something, that thing is going to have a main to kick off everything. It's taught, the virtual machine is taught to look for that. As of Java 8, the Java virtual machine for any class that extends application, instead of looking for the main, it's trained to look for the start. For JavaFX applications that were prior to 1.8, there was also a main, but we'll look at that when we do some IDE stuff, and sometime we may need to add that. I'm not going to cloud us with it at this time. So just know that we have to have a start. Now, one of the things that goes with start is a concept that we may or may not realize we've already worked with, but I'm going to kind of talk about it as more formally as a concept, and I'm also going to introduce something you may or may not have seen before. So right above the start method, I put a tag that says @override. This tag is called an annotation. Annotations are pieces of what we might call meta code, because they give instructions to either the compiler or the runtime environment, but aren't specifically part of the application. They don't perform a function of the application. They are more meta in that they are messages for the compiler or the runtime environment. And in the case of override, it's a message that tells the compiler, I know that public void start that takes in a stage as an input or argument is part of the inheritance chain for my superclass. It's either start is either in application or in one of its parent classes. And if I go up to JavaFX and I go into application and I go to my method summary, you'll see right here there is a start that takes in a stage. And it is void. We'll talk about what abstract means at another time. But just understanding that start is a method within application, but that I'm going to make my own version of it, that's what overriding is. We learned about overloading in an introductory course where we created multiple methods with the same name but different signatures. Here we're dealing with a method with the exact same signature so that we're replacing or overriding the other one. That is done generally because we want our method to do something very specific that is different than the one in the superclass. And when we make JavaFX applications, we will always override the start. We'll talk about why we always override it probably in the next week or 2 weeks. So in here is where the quote-unquote action is going to happen. One of the things we definitely need to do is, now there's a stage involved. So I'm going to add the import javafx.stage.stage. That's going to give me my stage class that I'm working with. And now I'm going to make some localized variables, objects. We could even call them properties, although since we're not really making employee test FX objects, they're kind of not properties. But I'm going to put them at the global level. And one of the things that's a part of my own personal style is I generally make put my variables at the highest level that makes sense. I don't want to put everything at the root level, the highest level, so that they're used everywhere. But anything that has the potential to be used in more than one method, I'll put at the class level rather than at the method level, because what happens is then we have to do a lot more passing of objects. And when we have our discussion or our lesson on aggregate objects, and you see some of the pitfalls we can have when we pass objects around, it's going to make it'll make a little more sense why we might want to do it this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I'm going to create an object of my employee type, both because we're not going to be able to enter any data into this interface and make magic happen, because because we don't have any events to handle. Without being able to handle events, we can't push buttons or do things to make stuff happen. So that's one of the reasons, and the other is, since this is testing the employee object, we're going to create one to test with. Now I'm going to add some controls, interface controls. One of the things I like about JavaFX is that the controls are all very logically named. A label is just that. It is a static piece of text that displays some piece of information to label something. And then what we might label is like a text field or a box in which we type non-static data or data that can change. So in order to tell the person, the user of your application, what to type in the text field, we need to label it. We're also going to make a couple of radio buttons here just for some variety. I'm going to make one called a mail button, and that is going to be a new radio button. Now, one of the things that's interesting, depending on your definition of interesting, about radio buttons is they're self-labeling. So we don't have to create a separate label object. We can specify a label text for that radio button. So I'm going to make two radio buttons, a label, and a text field. And that's what I talked about when I made the comment up above. So, so that should make sense. Now, beyond the application level, which is sort of the window that holds everything, JavaFX uses a sort of theatrical metaphor for all of its pieces parts. And that's hinted at here by the fact that when we start, we're starting on a stage. We call it primary stage. Remember, that's a user-defined variable. You could call it Frank or just stage with a lowercase s. Most people I know use primary stage, but that's not a hard and fast rule. You can technically have applications with multiple stages. We won't be making any in this class, but but we'll still go ahead and use primary stage for our stage name. On the stage, what we need to do is put a scene, because when you go to the theater and you watch a play, scenes are played out on the stage. So we're going to have a scene to go on our stage. For now, I'm going to declare the scene, but I'm not going to instantiate it. I'm not going to create, and I lost my text somehow. I'm not going to create the object. I'm going to do that inside the start method, and the reason for that will become clear shortly. Another thing that we need to do is we need to decide how the things that occur in the scene are laid out. So what we normally do is we take a layout class like FlowPane, and that allows us to arrange the things that go in the scene on the stage in a particular order. The FlowPane works left to right, top to bottom, much like English writing or our code. Everything flows left to right, top to bottom. The FlowPane works the same way. So that means when we go to put the interface elements on there, we're going to want to put them onto it in the order left to right, top to bottom. We want them to be displayed. So with that in mind, let's sort of build our scene. This first line should be pretty obvious. We're just creating an object out of the employee class. No problem. The label should be fairly self-explanatory. As I said, it's going to be a static string. So in the constructor, I send the text of that string that's just going to be appeared on there. The text field's going to be a box in which we type. Now, one of the things that we want to do with that box that we type in is we want to size it. So we may do, or we can do that by set pref column count, and I am going to go with 14. I just know that works for this particular example. And you may say, well, why didn't you do that when we instantiated it? It seems, if we have to do it before we even use it, why didn't we do it there? Well, one of the things, if we look down here at our text field, and we look at the constructor summary, we'll see that there isn't one that allows us to set the pref column count. That we have to do that down here with this method. So I'll just do it here because I have to do it somewhere. Now the second thing I'm going to want to do is I'm going to want to pre-populate my name field. I want to pre-populate it with data, since I'm not going to be able to trigger an event when somebody types something in there. So I'm going to pre-populate it. So I'm going to call a set text method. Since it is a text field, it kind of makes sense that it has a text property, and by convention, any property has the appropriate set with it. And if I was, again, not sure, I could go in here and look at what there was, and while we don't see set text there, a text, because reviewing inheritance, because our text field inherits from text input control. One of the things you'll see down here is that methods inherited from javafx.scene.control.textInputControl includes set text. So if we weren't sure, we could look at that. And, at first, some of this seems labor intensive looking through this stuff. But when you get really comfortable with inheritance, polymorphism, encapsulation, you look frequently at java.comments and API documentation, which uses the same format, it starts to become easier and easier to read, and you know where to look for stuff. If I don't see it in the method summary, it's probably inherited. And if I expect to see something I don't see, and since they're web pages, you can also do search on page through your browser. So I'm going to set that text to employee1.getFirstName. Whoops. And I'm going to string concatenate on that to a space. I'm going to want a space between the first and last name. And then employee1.getLastName. And there you have it. Now for the radio buttons, just to see something a little bit different, is I'm going to say if employee1.getGender equals male, then we will do male button.setSelected, whether the radio button is selected or not, to true, the Boolean value true. Now, because when you use radio buttons in event-driven programs, there will be events for people to change them, to truly make things change. We want to get into the habit of when we select one radio button that we unselect the others. In this case, we don't really have to, but it's just a good habit to get into. And we'll say else if employee1.getGender equals female, we're going to do the opposite. So I will copy and paste from here and change this one to false, this one to true. And since there was a third one called unspecified, what we'll want to do is set them both to false. Because basically unspecified means other, or the person just doesn't want to disclose that information. So we won't make any assumptions, and we'll just not have it selected at all. Now remember, what I'm doing here is this is what happens beforehand. This is everything that's occurring here happens at the start. This isn't triggered by an event like you're used to. We'll see that next time. Here, we're just setting up the interface in a default manner. So when I show it running and I do stuff, we don't have any event handlers to do anything more specific. So we get down here, we're going to have canvas. Oh, I haven't made that yet. One moment. One of the things I haven't done yet is I talked about that layout. So I'm going to make a flow pane, and I'm going to call it canvas. From my swing days, I'm used to a more visual, like the painting, drawing type art metaphors that it used. So I'm used to thinking of layouts as canvases on which we paint our elements. So I often use a canvas. You could call it layout, or you could even call it flow pane with a lowercase f. All are acceptable. I've just chosen to call it canvas, and that is a new flow pane. There's nothing specific about it because flow planes run left to right, top to bottom. So we don't have anything that we are specifically setting about it. But we do need to put stuff on it. So one of the things, or this is how we generally put our items on our layouts. All of our layouts have a special collection called children, and on that, or in that collection, we can think of as a box or a container of the interface elements. So in order to work with that box, we need to have access to it. So the box is something that belongs to the flow pane, canvas. The box belongs to that object. So since it's a private object, I can't directly access it. I have to ask the object for it so that I can then use it. So when I call the getChildren method on canvas, I now have the children box. And one of the things you'll see, and you'll get very used to over time, are these sort of multi-layered dot operators, just like we did up here. When we do employee1.getGender, gender is a string. So when we do employee1.getGender, this highlighted portion refers to a string object. String objects have an equals method, and I can call equals, and so it's comparing the string value of female to the value in the string of employee1's gender. Likewise, when I call getChildren on canvas, this highlighted portion is a child container or box that allows me to put the elements in it. And when I call the addAll method of that child box, I can add multiple elements in order, left to right, top to bottom, that I want them to be displayed when we get there. You'll be seeing this incredibly repetitively throughout the rest of this class, so you'll get very comfortable with this. So now it comes the time to instantiate my scene. I'm going to make a new scene. And that scene, I want to put my layout on it, which is why I wanted to wait to instantiate it, because I wanted to build the the layout. I wanted to direct the players where they need to stand in the scene, and then I put the layout in the scene, and in a minute we're going to put the scene on the stage. These 200s are the width and height of the scene in pixels. Those, when we put the scene on the stage, and the stage in the application, it dictates the size of the window. So now we've built our layout. We've put the layout in the scene. Now we have to put the scene on the stage. We only have one scene, so that's the one we'll put on the stage. There's just one more thing I want to do right now with my stage, and that is set the title, which will kind of fill in what goes up here. And I'm going to set that title to Employee Information. And then I can do primary stage dot show. Lift the curtain, if you will. At that point, it's revealed. So from a code standpoint, like I said, it's going to build all these pieces parts, set values of different controls, then it lays them out, puts them in the scene, puts the scene on the stage, and the stage was already passed to the start for the application. So the stage was already part of the application, and when we hit show, it's going to reveal. And essentially, this is an application that kind of does nothing, but to display the huge amount of power that we're going to get out of inheritance here, I would like to, gosh darn it. I would like to, I'd like to run this and show you how much it does do. So we're going to do Java, we're going to compile the employee, and I made one mistake and one intentional mistake. The set pref column count, that is a true mistake. That's a typo. Column count, with any luck, that will remove that error. And so, I did unintentionally make one more mistake. I need to grab the employee class that we use in our last class. So I need to pull my person class and my employee class into the same folder as my FX. Now I should be reduced to a single error. This error was intentional because there's a concept that's going to play back into polymorphism as we move forward. In this case, it doesn't relate directly to it, but it prepares us with something that is going to be incredibly common in Java programming as we move forward. And that is something we call casting. if you remember from when we did, when we made the employee class, and the person class for that matter, we had a construct that takes in the first name, the last name, the age, the gender, and the employee number. The first name, last name, and gender were all strings. The employee number, employee ID, was an int, and the age was a byte. Now, one of the things you may or may not remember from your intro class is, by default, all integer literals are ints. So this 46 is an int. And since an int takes up 4 bytes and a byte takes up 1 byte, we cannot assume, or the compiler cannot assume, that this int will fit in the byte box. I, as a smart person and not a dumb computer, know that 46 is a valid byte and will fit in the box. So what I can do is I can put byte inside of parentheses in front of the literal, and I'm casting it. Essentially, I'm saying I'm casting int in the role of byte, and I know it can do that because it fits. So I'm telling the compiler to ignore what you know because I know better, and if I was wrong, I would lose essentially my value, and the program wouldn't work correctly, and I'd have to fix it. But again, in this case, I know it works because I know that a byte can go up to 128. So now that I've cast that, all my errors should be gone, and I didn't save. If you haven't done that one yet, then bravo to you. That is a mistake that is easy to make, and I do it all the time. And I have them backwards. If I had looked at my Java or my API documentation carefully, I would have seen that gender comes before age. But I didn't look carefully enough, so I have to swap the two. We'll get this error-free yet. One of the things that I like about doing the examples live is these opportunities to show debugging, and to remind you that no matter how much experience you have developing applications, you're still going to make mistakes. So it's important just to kind of see that, look at some of the error messages that are involved with what I'm getting, and I didn't read before because since I had intentionally not cast, I didn't read that I was already getting that cannot be converted to string error when I was intending to get cannot be converted to byte. That's what I get for not reading. But regardless of that, it's all fixed. So now we can run our application. And that's what we get. So we see that we have a window that I can move around, that I can minimize, that I can maximize, that I can restore, that I can resize, that has a title that I did with one line with this cool little application icon on it. As I resize, you'll see sort of the weakness of the flow pane layout. When it says left to right, top to bottom, that's what it means. And so, not not picking a good size for the window by default or something like that can result in an ugly interface, but I didn't want the layout to be the star here. We'll have plenty of time to look at other layouts. I'm more looking at what we're getting here. Now the label is static, like I said, so it really doesn't do much. But thing like this text box, on the other hand, that's quite a star. I can highlight text inside of it and change that to something else. I can backspace over it and type other stuff in there. All that ability is part of the control itself. I don't have to write any of that. Encapsulation, I don't need to know how it figures out what I'm doing, how to change the text, how to highlight it, all that stuff. I don't need to know any of it. I just need to know how to use it, and I have the API documentation to tell me. You'll notice similarly with the radio buttons, when I hover over a particular radio button, it ever so slightly changes color. I can click in it to select it and unclick to unselect. Now remember, even though I had the when it's male it unchecks female, when it's female it unchecks male, and when it's unspecified it unchecks both, those aren't part of an event handler. That's just the default, how to set the default values. The fact that I can select and unselect is part of the radio button itself. So in the event handler, you have to additionally do the select and unselect, so that when there's a change event, and we'll talk about events next time, it keeps track of everything. But all this functionality, I'm simply getting out of these controls by using them, and how that's done is encapsulated inside the code itself. So I can close that, and as you noticed, this is very little. This is 43 lines of code, including my brackets, and I have quite a few of those, my import statements. I'm just creating 4 interface elements, a layout, a scene, and just doing some very basic pre-setup, and I have a fully functioning app. Next time, this is going to get really interesting when we can create our own event handlers and make real things happen. So hopefully you're looking forward to that. A full commented version of this example will be up soon on the website. So look for that. And in the meantime, I hope that you found this interesting and are looking forward to event-driven programming. We'll talk to you next time. Bye-bye.